Hello, this is Kenneth, and today we're on the third video of the AMC problem series over sequences and series over problems involving or relating sequences in series. This is the third video, and once again, the AMC is perhaps the most prestigious or one of the most prestigious undercollegiate mathematics competition. It involves everything from pre-calculus and under, and it emphasizes problem solving over memorization. Just because you know how to solve or you know the process to solve a quadratic or something doesn't mean that you know how to apply what you know about it to situations and problems that you have never seen before. Alright, before we begin our first problem, we're going to have to know what an arithmetic sequence is. So, an arithmetic sequence is a sequence that looks like this. A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. Alright, so the sum of the arithmetic sequence that's going to be A plus D, this in parentheses, you don't have to, A plus 2D plus plus A plus n minus 1 D equals. So this is a sum of arithmetic sequence with n terms. Alright, this is going to be equal to 2a plus n minus 1 d over 2 times n. Alright, now that we got that, we can begin on our first problem. Let A1, A2, AK be a finite arithmetic sequence with A4 plus A7 plus A10 equals 17 and A sub 4 plus A5 plus A6 plus plus A12 plus A13 plus A14 equals 77. If A sub k equals 13, then k equals. I'm going to give you guys a moment to think about this, or I encourage you to pause the video and solve the problem ahead. Alright, so from this problem, let me get my pen. From this problem, we know that the nth term in the sequence, A sub n, is going to be equal to A plus n minus 1 times D. So if we know what A and D are, then we can figure out what n minus 1 is. And k in this case is n, so we can figure out what k is. Alright, I want to show you guys a trick here that you guys probably don't know. But first, before I can show you that trick, you have to recognize that this is also an arithmetic sequence. Alright, so if you do recognize that, and you also recognize this, then look at this trick. It's A4, the sum, plus A7 plus A10 equals 17. You can divide this by 3 and divide this by 3. What does this mean? If you take if you add 3 different terms and you divide it by 3, that means you're taking the average of it. The average is going to be equal to A7. Here's how I got that. Look at this. I can say that this is A4 is A plus 3D, because AN is A plus N minus 1 times D, plus A plus 6D plus A plus 9D. Alright, divided by 3 equals 17/3. Alright, now I'm going to continue. And now I get 3A plus 18D divided by 3 is equal to 17/3. I can factor out the 3 and cancel it with the denominator, and then I get A plus 6D equals 17/3. And A plus 6D, by definition, A plus 6D is equal to A sub 7, which is equal to 17/3. That's the trick. The trick is the average of an arithmetic sequence, and this is an arithmetic sequence. The average of an arithmetic sequence is going to be the middle term. That's the trick. Alright, so we know this is A7, and by extension, by the same token, right? If the average of the arithmetic sequence is the middle term, then the average of A4 plus ... plus A14 equals 77. The average of that. Well, consider that there are actually 11 terms. Well, first, let's count. A4 is one term, A4, 1, A5, 2, A6, 3, A7, 4, A5, A8, 5, A9, 6, A10, 7, A11, 8, A12, 9, A13, 10, and A14, 11. So there are 11 terms, right? So if there are 11 terms, then what we can say is the average of that, which is equal to A9, because A9 is the middle of that, right? So A9 is going to be equal to 7 divided by 11, which is equal to 7. Alright. So we got 2 different A values. How is this useful to us? Actually, it really is useful. Think about it. Think about what we can do. What operation we can do between these 2 A values. I'm going to give you guys a moment to think about that, because this is such a crucial step in problem solving. Alright, so what we can do, and it doesn't come out of nowhere. We want the D values, right? So what we can do is we can say that A9 is equal to A plus 8D. And if we have 2 values, right? We're trying to relate A7 and A9 by an operation. If we have 2 variables, then we're not going to solve for any. But what if we subtracted and we say that A9 is A plus 8D and A7 is A plus 6D? So we're going to subtract both of them. We're going to get A minus 6D. And then now we got 7 minus 17/3. Alright. And this simplifies to the A's cancel out. And 8 minus 6 does 2. 2D equals 7 minus 17/3. We gotta make that a common denominator, so that's 21 multiplied by 3 divided by 3 minus 17/3. Alright? That's 2D equals to 4 third. And then what we can do here is we can divide both sides by 2, which is multiplying the reciprocal, which means that D equals 4 6, and we can simplify that. That's 2 thirds. So D equals 2 thirds. Alright, so now we got D, so we can solve for A. We know that A equals, not A. Let me erase this. We know that from above we know what a7 and a9 are, so we can solve for one of them. We can solve A by using one of them. All right, so we're gonna use a7, and that's equal to 17 thirds. So A plus 6 times 2 thirds equals 17 thirds, because we know what D is now, right? So we multiply both sides by 3. That cancels out the denominator. We get 3A plus 12 equals 17. Alright, now what we can do is we can subtract 12, so we get 3A. Oops, my pen's going crazy. 3A equals 17 minus 12, that's 5. And divide by 3, so A equals 5 thirds. Alright, so now that we got A and we got D, we can solve AK now. So AK equals A, which is 5 thirds, plus K minus 1 times 2 thirds, which is D. This is equal to 13. So we're trying to figure out what K equals, right? And then we can continue. We can multiply everything by 3, and that would be 39. So 5 plus K minus 1 times 2 equals times 3. It's going to be 39. Alright. Now what we can do is we can subtract 5, and we get K minus 1 times 2 equals 34. We can divide by 2, we get K minus 1 equals 34 divided by 2, 15 plus 2 is 17. And then we can solve for K equals 18. Alright, we solved it. And is 18 up there? 18 is up there. Alright. So what's the big idea here from this one? And if you haven't seen my other videos, big ideas are how I learned to problem solve. And not everyone needs to do it, but it helps me. The big idea essentially is how can you extrapolate what you learn here, like the techniques, because sometimes it looks like you pull these techniques out of nowhere, like it's random, right? So yeah, of course it's gonna be random the first time, and you're gonna be like, whoa, that's a new technique, and I didn't know that I should apply it to that. But then you should look at the technique and look at the randomness of it, right? Like how he pulled it out of nowhere, and think of why, like, oh, this technique helps solve this form and stuff like that, right? And then you eventually realize that if I apply this same technique to any other problem that has a similar form or a similar structure to the problem we're solving, then it might lead us somewhere. So it's kind of like so you don't guess on the other problems. Alright, so the big idea here is to know that average of arithmetic mean is, note the average of the arithmetic mean is the middle term. Alright, that's the big idea, I would say. Yeah. Alright, on to the next problem. Well, actually, let's do some prerequisites before next problem. Some prior knowledge that we have, that we need to have before next problem. So, a geometric sequence is something of AR squared, AR cubed, AR fourth, ... ARN. Alright? Sum of geometric sequence with n terms is, the sum of geometric sequence with n terms is a times r to the power n minus 1 divided by r minus 1. And this is also equal to a times 1 minus r to the power n divided by 1 minus r. Alright, sum of infinite geometric sequence. The sum of infinite geometric sequence where the absolute value of r is less than 1 is equal to a 1 minus r. Alright, it wouldn't make sense to take the sum of an infinite geometric sequence if r is bigger than 1. So with that said, let's work on our second problem. The following infinite geometric sequence with the absolute value of r less than 1, a plus ar plus ar to the power of 2 plus ... has a sum of 7. And the terms involving odd powers of r have the sum of 3. What is the value of a plus r? I will give you a moment to think about this. And as always, you can pause the video, which I do encourage you to do. Alright, let's begin. So, r is less than 1, and it's an infinite geometric sequence, and it has a sum of 7, so that tells us a 1 minus r equals 7. Alright, the terms involving the odd powers of r have the sum of 3. Well, let's write down the geometric sequence. That would be r, that's an odd power, r to the power of 1, which is an odd power, ar3, that's also an odd power, ar5, that's an odd power as well, ... And if you notice, this itself is a geometric sequence with a common ratio of r squared. So that means that the sum of this is going to be equal to ar divided by 1 minus r squared. And that equals the sum of that, which equals 3. Alright, so from there, what we can do is we could say AR divided by, and we're applying the difference of cubes here. And then we get 1 plus R, 1 minus R, that equals 3. From there, we solve for A, and A is equal to, oh wait, we can just say A 1 minus R, that's equal to 7, so we got 7 times R 1 minus R equals 3. Multiply both sides by R, and you get 7 times R equals 3 minus 3R. Alright, 3 minus 3R. Alright, so you add 3 to both sides. Oh wait, that's wrong. It will be plus R. So 3 plus 3R, right? So you subtract 3R from both sides and you get 4R equals 3. Divide by 4 and you get R equals 3/4. Which makes sense because R is indeed less than 1. Alright, so we have the value of R. We can plug it into this and we can solve for the value of A. So A is going to be 1 minus 3/4 equals 7. And that would be A divided by 1/4 equals 7. So you multiply both sides by 1/4. So you get A equals 7/4. A equals 7/4. Alright, then what is A plus R? A plus R is going to be equal to 3/4 plus 7/4. They both have a common denominator. So therefore is equal to 10/4, which can be reduced to 5 halves. The answer is E. 5 halves. What's the big idea here? Not every problem has a profound big idea, but I'm trying to make one for each problem. What is kind of thing that helps us? Well, I would say it's this right here. It's definitely this. This has some profound meaning. Right? You have to realize that the common ratio of that is R squared. So the big idea is essentially it's kind of like look for a pattern, which is kind of vague. So you don't really have to write it down. You can skip over it when you're looking over big ideas. Look for a pattern. But that's essentially the big idea here. Or a common difference. Look for a pattern. Yeah, it's the same thing. Alright. 5 halves. So on to the third problem then. A sequence of 3 real numbers form an arithmetic progression with the first term of 9. If 2 is added to the second term and 20 is added to the third term, the 3 resulting numbers form a geometric progression. What is the smallest possible value for the third term of the geometric progression? I'll give you guys a moment to think about this. Alright. This one would definitely have a more of a conceptual idea than the last one we did. Which means more big ideas, or the big ideas for this one carries more meaning. Alright. A sequence of real number form a geometric progression. So let's see. an arithmetic progression with the first term of 9. So you got 9. You got 9 plus D. And you got 9 plus D, 9 plus 2D. Okay, that's the arithmetic sequence. Now, if you add 2 to the second term and 20 to the third term, you get a geometric. 9 add 2 to the second term, that's 11 plus D. And add 20 to the third term, that's 29 plus 2D. This is a geometric. Okay. What is the smallest possible value for the third term of the geometric progression? Alright. Let's think about this. Well, let A, B, and C, this is abstract, we're thinking abstractly. Let A, B, and C be a geometric progression. Be a geometric progression. This means that AR equals, this means that, well, actually, what I wanted to say from this is, what is the relationship between A, B, and C? Without any other terms, just the relationship between A, B, and C. Actually, I want you guys to pause the video and think about that. Alright. So the relationship between A, B, and C is that B is going to be equal to AR and C is going to be equal to BR. So the relationship between this is that BA equals CB, and both of that equals R. So therefore, if we don't worry about the R, we see that B squared equals A times C. Alright. So, what's the point of all of this? The point of all of this is to introduce is sometimes when you get stuck, find the relationship between the variables. Like, you can look here, right? And you will have no clue what the common difference is. I mean, the common ratio is. No clue about R. So that will eventually lead you to think about the relationships. Well, it should lead you. Alright. So therefore you have B squared, so you can say 11 minus D squared equals AC, which is 9 times 29 plus 2D. 9 times 29 plus 2D. Now you have a quadratic, so you can maximize it by getting the smallest D value and then plugging it into 9 plus. Oh wait, plugging it into 29 plus 2D. Pardon me, and that will give you your smallest third term. So 11 minus D squared. Let's multiply that. So we get 121 minus 11 times D plus 11 times D. That's 22 D minus plus D squared. And that's equal to 9 times 29. 9 times 9 is 81. So we got 81. And 9 times 20, that's going to be 1 less than 200. 1 multiple of 20 less than 200. So that's going to be 180. and we have to add 81 to 180, so that is 261. All right, so we got 261, just 261. There's no d value after that. And we got 9 times 2d, which is 18d. All right, so what we can do here is we can combine everything and let's move 261 and 18d to the other side. So what we get is negative 22 minus 18, that's going to be negative 40d. So we got negative 40d, 261 minus 100, and no wait. Yeah, we can take the negative of that after we subtract it. So 261 minus 121, that's going to be 140. So negative 140 plus d squared. All right, that was a lot of arithmetic brain power. So we can divide everything by 20. Yeah, we can divide everything by 20, and maybe even and maybe some multiple after that. So we get d squared. Oh wait, we don't want to do that because d squared is known, so we don't want to do that. That would be bad if we do that. Alright, so we don't want to divide anything. Let's rewrite this. We got d squared minus 40d minus 140 equals 0. Perhaps you know how to factor this. I can't think of any way to factor this right now. And that actually makes absolutely no sense, considering that all of the answer choices are whole numbers. So I probably made a mistake here. And I see the mistake. It's 11 plus d. You guys should have helped me. There's a computer screen. 121 plus 22d. So, this right here, negative 40d. Let's erase all of this, because that's all wrong. Erase. Oops. It doesn't work. Alright. It's not negative 40d. Get all of that out of my face. It's going to be 140, like I said. 140. 22 minus 18, so it's going to be 4d plus d squared equals 0. This makes more sense now. D squared plus 4d plus 140 equals 0. So what could what could this factor into? And this actually factors into d minus 10 and d minus 10 and d plus 14. All right. So if it factors into that, then that means that d equals 10 or negative 14. The lowest value is negative 14, so 29 plus 2d, 2 times negative 14 equals negative 28. So the lowest value of 29 plus 2d equals 1. All right. So what do you think the big idea is here? Well, The big idea is to know the relationship between the terms of a geometric progression. Terms of a geometric progression. And similarly, know the relationship between the terms of an arithmetic progression, which we haven't covered yet, but knowing so will reduce unnecessary variables. And the relationship between an arithmetic progression, well, there's a common difference, d. So let's say we have a, then the relationship between a, b, and c is that b equals a plus d, and c equals b plus d. So we solve all in terms of d, then we get b minus a equals c minus b. And now we can put it in terms of b, and we get 2b equals a plus c. So this reduces the need for d. There's a relationship between the variables that doesn't need d. So the relationship between the terms of an arithmetic sequence. Alright, let's do another problem. So it says, consider the sequence defined recursively by u sub 1 equals a, which is any positive number, and u sub n plus 1 equals negative 1 divided by u sub n plus 1 on parentheses, except negative 1. N equals 1, 2, 3, and so on, for which of the following values of n must be u sub n equals a. I'm gonna give you guys a moment to think about this. However, one of the thing is, this isn't a geometric series or a arithmetic sequence. This isn't a geometric sequence or an arithmetic sequence, and this is just a general sequence. And one of the main techniques with dealing with a general sequence is just to compute some terms, and hopefully you find a pattern between the terms that you can generalize, or it's cyclic. And we'll see what that really means whenever we solve this. So let's begin. Oh, and I didn't include the multiple choice answers for this. Here are the multiple choice answers. Alright. I'm sorry. So you can still pause the video if you need more time, but I'm gonna begin. So we're gonna start off by computing some terms, u1 equals a, u2 equals -1 divided by a plus 1, u3 equals, why didn't we stop at u2? Well, there's no pattern. We didn't see a pattern. So that's why we're continuing. u3 equals -1, -1, -1, a plus 1, plus 1. So we're starting to see something here. We're starting to see that the fraction on this side repeats and it will get smaller and smaller. But let's see if we can also see something else if we simplify it. So let's simplify this. u3 is going to be -1. And it doesn't harm to simplify it because we still can go back to this if simplifying doesn't really work. So we get -1, -1 plus a plus 1 divided by a plus 1. -1 cancels out. And then you're left with u3 equals, multiplying by the reciprocal, you get -a minus 1 divided by a. Alright, u4 -a minus 1 divided by a. Okay, u4 is going to be equal to -1, -a minus 1 plus 1, and this is over a. Let's see if we can get somewhere by simplifying that. That would be u4 equals -1. The pluses cancel out. So you're -a over a, and that's -a over, oh wait, this is an a right here, so the a's cancel out because we have to make a common denominator. So the a's cancel out, then this should be that should be a -1. So -1. So you're left with -a over -1, and then you just get a. All right. So that's actually profound because u1 equals a, u2 equals -1, a plus 1, u3 equals negative a plus 1 divided by a, and u sub 4 equals a. So that means well, you can continue again, you can find u5, u sub 5, but because the formula, it's recursively defined, the formula is defined, right? So you're gonna get the same value as u sub 2. So therefore it's cyclic, it repeats. It repeats with a period of 3. Because every 3 iterations we get a. Repeats with a period of 3. So that means that u and a has to be a multiple of 4. And the only thing the multiple of 4 is 16. So, not A. So, oh wait, I meant to write answer equals C equals 16. Alright, what's the big idea? Usually, look for a pattern for a pattern by look for a pattern by computing some terms. Alright, look for a pattern by computing some terms. Let's do another problem then. Alright, so for this problem it says, consider sequences of positive real numbers of the form x, 2000, y, and so on, in which every term after the first is one less than the product of its two immediate neighbors. For how many different values of x does the term 2001 appear somewhere in the sequence? 1, 2, 3, 4, or more than 4? I will give you guys a moment to think about this. Alright, so if you recall one of the big motifs or big ideas from the previous video, solving equations and systems, it's good to put everything in terms of each other. We see two different variables here, so we can put the y in terms of x. That will simplify things a lot. So it says that every term is one less than the product of its two intermediate neighbors. Well, that means that 2000 equals the product of is one less than the product of x times y minus 1, right? Because it's one less than the product of its two intermediate neighbors. So if we solve for y, we get 2000 plus 1 divided by x equals y. And then we get 2001 divided by x equals y. Alright, so for next term, what we do is we know that y is the product of its two immediate neighbors minus 1. So y is 2001 divided by x equals 2000 times b, and that b be the term after y. So times b minus 1. And if you solve for b, then you get the next term in the sequence. So solving for b, you get 2001 divided by x plus 1 equals 2000b. Alright, and then you divide by 2000. So let's simplify the left hand side first. You get 2000 plus x divided by x equals 2000b. Alright, and solving for b, you get 2000 plus x divided by 2000x equals b. So now we got the third term. We can keep going on because it doesn't look like there's a pattern so far. To find the next term, we get 2000 plus x. There's a mistake somewhere. right here, and no one corrected me. The mistake, it turns out, is that this is actually supposed to be a 1, not 2000. Erase this too. And erase this. Alright. Let's put 1s there. 2001. Let's see. 2001 plus x. 2001 plus x. 2001 plus x divided by 2000x. Alright. Now we have to multiply it by the 2 immediately. So doing that, we get, that is equal to the preceding one, which is 2001 divided by x. 2001 divided by x times b minus, undo that, minus 1. Solving for b again, multiplying by x, you get 2001 plus x divided by 2000x plus 1 equals 2001 divided by x times b. Alright, continuing, we get multiplying everything by x, the x's cancel out on the first one, so we get 2001 plus x divided by 2000 plus 2000x over 2000. Alright, which is just plus x. I did that so we could have a common denominator, and that equals 2001b. Alright, let's simplify the left hand side. We get 2001 plus 2001x divided by 2000. 2001 plus 2001x divided by 2000 equals 2001b. Alright, now if we divide by b, we get a lot of things cancel out. We get 2001 times 2000. We can factor out the 2001s. In the numerator, we get 1 plus x. 2001 cancel out, and then we have b. So simplifying, 1 plus x divided by 2000. And it still doesn't look like we have a pattern. So let's continue. 1 plus x divided by 2000. That's going to be equal to the preceding term, which was 2001 plus x divided by 2000x. Alright, now what we can do... Oh wait, we didn't finish the expression. Times b minus 1. Alright, so now what we can do is we can solve for b. Let's go over here. 2001 plus... Pardon me. 1 plus x divided by 2000 plus 1 times 2000x divided by 2001 plus x. And this equals b, but we're going to simplify it. So we have 1 plus x times 2000 over 2000x. So this is essentially this is 1 plus x plus x plus x squared plus 2000x divided by 2001 plus x. Now this is going to simplify to 2001x plus x squared over 2001 plus x. You can factor out the x and you get x times 2001 plus x over 2001 plus x. This cancels out, and then we're just left with x. Now, if we continue it, we're gonna get x equals the preceding term. Where is the preceding term? X equals 1 plus x over 2000 times b minus 1. Alright? And then what we can do is we can say x plus 1 multiplied by 2000 divided by x plus 1 equals b, and then this cancels out, and then we're left with 2000. Alright, do you see a pattern here? Look, this is the original term, right? It was here, let me write in blue. It started off with x, 2000, y, and y was 2001 over x. So 2001 over x, and then the next term was 2001 x plus x divided by 2000x. 2001 plus x divided by 2000x. The next term is, pardon me, somewhere here. 1 plus x divided by 2000. 1 plus x divided by 2000. Then from there we got x. Then from there we got 2000 again. So it's starting to repeat. It's cyclic, right? Let's try and get it. Cyclic. Alright. So in the series, the original series, before it starts to repeat, these are the terms that we have to consider. Right? How many of these does the term 2001 appear in the sequence? Alright, so what we can do is we can set we can set all of these equal to 2001, all of the ones that contain x, right? And if we do that, if we set all the one that contains x and we solve for x and x's are positive and they're different, then that term contains 2001. And doing so, which I'm not going to do, you get four terms that contain two. Wait, I want to write in white. Four terms contain 2001. Alright. That's it for today's problem solving series. Let's write the big idea for this. Big idea. It's to the big idea for this is to look for a pattern by computing some terms. And regardless of whether it looks like you're not going anywhere, it generally does go somewhere, especially with sequences and series. Alright. May you guys have a good day, and thanks for watching. Please like and subscribe.